Teamcenter Simulation Process Management allows you to get control of your simulation data. In this short demonstration, you'll see how Teamcenter Simulation is useful for managing a workflow where design changes occurred and needs to be revalidated for structural integrity. We start with the engineering manager, Mary, who accesses Teamcenter via the web-based client Active Workspace. In Mary's latest working directory, she has two items: a passenger car sunroof subassembly and a roof bow component. She selects the latest revision of the roof bow and sees it's a member of the sunroof subassembly. Mary then checks to see what objects are attached to the roof bow, and she sees there are design requirements. These requirements indicate the roof bow must be revalidated and that its stress must not have increased more than 10% and its absolute deflection has not increased by more than 5% from the original design. She therefore then needs to assign this to an analyst. To do so, she initiates a new CAE process and workflow based on an existing template, assigning the simulation to the analyst. By going to her mailbox, she can see the workflow she just initiated, and checks the flowchart of the workflow, which indicates the first two tasks are complete, and the next step is to perform the analysis. We now switch to the analyst, Kurt, who logs into Teamcenter. Kurt goes to check the new mail in his inbox, and it's a task assigned earlier by Mary. He can also view the same workflow she was looking at, indicating the current task to perform and the new requirements Mary was referring to. Another time-consuming activity in traditional development environments is understanding and tracking relationships between CAD and CAE data. The CAE manager in Teamcenter allows Kurt to quickly perform an impact analysis to completely understand these relationships, whether it's a workflow, a requirement, a finite element mesh, simulation results, or the enclosing folder. Kurt can also view the sunroof assembly in detail directly within Teamcenter without any additional tools. This is accomplished through a lightweight representation of the model using JT, and by zooming in on the roof bow, he can see the design change with the new oval pocket. Kurt the analyst wants to ensure whether the only component that's changed is indeed the roof bow. Teamcenter Simulation can help him check if other components have changed as well. Rather than visually inspecting the parts, Kurt leverages Teamcenter Simulation's ability to track the latest revisions. Here he sees there's one item highlighted in red, which indicates the part is changed from its initial revision in the assembly. Kurt then confirms the component number that he just identified is indeed the roof bow, and that no other components have been redesigned in the assembly. He now needs to mesh the part. Another powerful capability Teamcenter Simulation provides is the ability to automate simulation processes directly from within the data management system. This means Kurt can send a part or multiple components off to a batch mesher, which could be NXCAE or any other FEA preprocessor with batch meshing capabilities. In the case when multiple components need to be remeshed, this automation capability is a significant time saver. After the part has been meshed, Kurt opens NXCAE to validate the roof bow has been meshed correctly. Note that within NX in a managed environment, he can directly select items from his working directory from Teamcenter. By displaying the individual part, he can observe the mesh generated by the batch mesher, incorporating the new pocket feature. With the modified part now meshed, he is ready to clone his existing solution in NXCAE and solve it. Cloning ensures he keeps his existing results and can compare it to his new results. Kurt now reviews the results, starting with the displacement results. He sees the maximum displacement of 2.98 millimeters occurs at or near the middle of the roof bow where the design was changed. Kurt wants to capture this information in a report, so he first generates a JT snapshot and then creates the report. He will include snapshot images that are automatically generated in the report. The design requirements stated that stress should not exceed 10% of the original design. To check the stress, Kurt drops the stress post-processing template on the model to verify maximum stress and its location, generate images, and ensure it meets the design requirements. Kurt's results and report are then automatically saved into Teamcenter with all the right relationships to the CAE data and ultimately the correct CAD revision. Going back to Teamcenter, Kurt can now view the JT results he generated and quickly mark it up to provide feedback to his manager, Mary, informing her that the new design meets the requirements. Kurt then goes back to his work list in Teamcenter and includes the marked up images as a reference item to his assigned task. Finally, he adds comments indicating that the section was reduced and within requirements, and that the stress remains unchanged for the revised roof bow design. We now switch back to Mary, who received notice that the task she assigned is complete. She can now view the results for herself directly from her web-based client without the need to launch a CAE-specific tool. She then also reviews the report submitted by Kurt. In summary, Teamcenter Simulation Process Management is a powerful tool to manage all of your simulation processes, data, tools, and workflows in context with all of the other product data you're already managing. As you just saw, engineering teams using Teamcenter Simulation can ensure they are analyzing the correct design variant, tracking the right requirements, and following the correct simulation processes. This helps organizations to ultimately drive product development more effectively.